Now let's prove the following result. We assume that A1, B1, A2, B2 are real numbers. We want to prove the following inequality. Okay, so sometimes it's good to look at the inequality and see what it means. Okay, if we look carefully, we see that we have the square root on both sides. Okay, so one way of solving this problem is that we can square both sides, but doing so will require a bit of work. Okay, instead of that, we're gonna do a geometric approach to this inequality. Okay, so we're gonna introduce a rectangular system x o y. Okay, in such a way that we can set some coordinates. Okay, so here if we assume that we have this point A and this point B, and A has coordinates A1, B1, and B has coordinates A2, B2. Okay, so now we can set them in such a way, in the following manner. Okay, here we have we set OA as A1, B1, and we set AB as A2, B2. Okay, we do it in this manner here. Now we see that we can write OB as A1 plus A2, B1 plus B2. Okay, now we see that we can use the triangular inequality. Okay, we have OB is OA plus AB, and therefore the norm of OB is less than the norm of OA plus the norm of AB. Okay, so the norm of OB, we know that that's from here we get the norm that it's just the square root of A1 plus A2 squared plus B1 plus B2 squared. It's going to be less than the norm of OA is just the square root of A1 squared plus B1 squared plus the norm of AB, which is the square root of A2 squared plus B2 squared. And in this case, we prove the result very quickly. Okay, and if we set the problem this way, we find it easily. Instead, if we try to square both sides, okay, we're gonna have another square here. Okay, and this will get messy as we keep going. Okay, so the key here is that we can apply the triangular inequality here. Okay, and apply the norm of vectors. Okay, so the Euclidean norm, the norm of OA is this one, and the norm of AB is this one, and the norm of OB is this one here. Okay, and the triangular inequality, by setting the values, we get the result that we need. Okay, so this is a quick way of proving this result. Okay, we can generalize this result to more than 2. Okay, and if we prove this one here for this case, we can set it for the more than 2 vectors. Okay, thank you very much.